Hello YouTube. This video, or most likely video series, is going to be about a book that I've always wanted to read. It's a book about how to write interpreters and compilers, and the first part in the book actually uses Java for writing an interpreter, and the second part uses C, if I recall correctly, for writing a compiler. But I want to try to do it with Rust. So let's just start by, and here's the book. It's called Crafting Interpreters, but even though it's called that, it also has a compiler section, compiler part. So because of that, let's make a project called CI for Crafting Interpreters, and the first part will be an interpreter, so let's call it CII, why not? But okay, let's get started. So I just want to see here how I can get it. Download free sample? No. So it used to be that you could get it for free, but it doesn't seem to be the case anymore. Read the whole book for free, really. Okay, there it is. Okay, blah, blah, blah. So I'm not really gonna read this right now. Maybe I'll read it off camera. But you may can read it, but you may read it as well. But the point is that we'll implement a language called logs that this guy, the author, has made up, and it kind of looks like this. Okay, whatever. It's a high-level language, good. Dynamic typing, automatic memory management. That's going to be interesting to see how we implement that in Rust. Data types, booleans, numbers, strings, like a null thing. Expressions, sure, arithmetic, unary operators, comparison operators, logical operators. Nothing too weird here. Variables, control flow, everything looks super normal. You define a function with fun, and as a return keyword, you can define local functions. So there's also some scoping, I guess. You can return functions, so it's a functional language. Classes, that's great. Inheritance. Now there's something with a standard library. Set of functionality is implemented directly in interpreter built on top of. This is the status logs. We only need to demonstrate that code is running, doing what it's supposed to do. Some optimization. So apparently the standard library will have print and clock, but whatever. Okay, great. So it's basically like pretty standard language. The print function or statement, whatever you want to print, operator, you could even call it. It doesn't look like a function like it does in most languages. Everything else is super normal. So you can see here what the book is about. It's about a tree walking interpreter and a bytecode virtual machine. So it's actually not a compiler as such. Well, you're compiling to bytecode. Now, probably the reason that he's not compiling to native is because it's like very specific to the type of machine architecture you have, and unless you want to use LLVM or something like that. But let's worry about that when we get to it. So with this part we begin JLogs. So maybe we could call our thing JLogs or something like that. No, we just stick with the current project name. So programming languages are a huge topic with piles of concepts and terminology to cram into your brain. Okay, we gotta have mental rigor. Oh no, that's not good. Implementing an interpreter uses a few architectural tricks and design patterns uncommon in other kinds of applications. That's why we want to do it. We want to learn something new. So we'll be getting used to the engineering side of things too, giving all of that. Keep the code we have to write as simple as plain as possible. And as I said, he's writing Java, but we'll stay away from that. Okay, so the first few chapters are these phases of the interpreter: scanning, parsing, and evaluating code. And I have to say, I've never really written an interpreter. I've once written a small Lisp interpreter, but I don't really know how to write a good interpreter. So I'll be learning about that as well. After that, we had language features one at a time, growing a simple calculator into full-fledged scripting language. Sounds good. Take big bites. Anything worth doing is worth overdoing. Interesting. Okay, the first step is scanning, and it just also called tokenizer in other contexts. So it takes characters, or the string that you put into the source code file, and outputs tokens. It's not supposed to be hard. Pretty much a switch statement with delusions of grandeur. It will help us warm up before tackle some more interesting material. By the end of this chapter, we'll have a full feature fast scanner that can take any string of logs, source code, and produce tokens that will feed into the parser in the next chapter. Okay, whatever. Since we need to sketch out the basic shape of our interpreter, everything starts with a class in Java. Now here we are so lucky to work with Rust. We don't need classes. Okay. This is interesting. I actually don't know how to read in arguments for us, so I'll have to look that up. I will be right back. Okay, apparently this is how it looks. You use std-env, you gather the args like this, and then you can print them. So let's try to run this. Arg1, arg2, arg3. And then you can see here it's printed the arg. The first one is always the executable as per usual. Then there's the args we give in after. So now we have that. We can do what it says here. If args.length is greater than 1, then we are just going to print a line that says usage. and then we will exit. Can we do that? 64. Keep putting parentheses. We'll say run file of args the first. As we'll say run prompt, and then we debug. So stick that in text file and get your IDE or a makefile or whatever set up. Good. Okay. Logs is scripting language, means it executes directly from the source. Our interpreter supports two ways of running code. If you start logs from the command line, give a path to a file, it reads the file and executes it, like Python. So let's define this run function. It shall take a path which it's a reference to a string. And now we need to read the file. I also forgot how to do that. One sec. Okay, so this is how you read a file. You say use stdfs. You read to string on the path, and it returns some kind of error or something. So for now, let's do something like this. So, okay, exit doesn't exist. Exit doesn't exist, and that's because we need to use std process. Now we can try. Still doesn't work. What did I do wrong? Because I just found it over here. Okay, great. Okay, so it complained about that. So that's because arguments apparently work a little bit differently than in Java. There we go. And then it panicked that it couldn't read file. So here is the problem. The file didn't exist, and we want to kind of fail gracefully if the file doesn't exist, right? So let's look in here inside fs, read to string. It returns a result of string. Now, this one doesn't really have anything, right? So what happens if we do this? I didn't like that. It did not like that. We can do this like they do over here. Let's try that. What is this error thing? Let's try. Okay. Must include the dim. And then we have to box it as well. It's getting a little bit complicated. You know what? Let's do this. And let's say match this guy with a how do we do that? Error, and then we will say return. No, wait. Great. Error matches any value, but if we say like this, great. So now it's running, and then down here we can do like some graceful error handling. If it's okay, we do nothing. If it's an error, we will say, let's get the message, we will say just print the message, and we will exit with an error code. Now we say run, and then it says error, no such file or directory, great. And then here instead we will say return run contents. And then let's go back to the book. Run, blah, blah, blah. If you want a more intimate conversation with your interpreter, you can also run interactively. Yeah, it will be a REPL. And we don't have this run function, but let's make it, and it should take a string. It should return either an OK or an error message, and for now it will just always return an error that says not implemented. Let's try to run it again. And we still need a toString. Okay, so if it's okay with contents. Great. Let's make a little source file. No, we'll do that another time. But let's implement this run prompt. And then so we have to figure out how to read a line. And now I found out how to do that. So here we will just say print this prompt sign space. We will say make a buffer and access standard in will read a line into the buffer, assume it goes well, and then we will just for now print it out. And run prompt should also return either a result or either an OK or an error, because then we can again error handle it like this. Just exit. Is this a message? Print an error. Like that. Perhaps you could try to recover inside the prompt, but for now this will do. Let's try to run it. Okay. Expected string because of this. So what is this read line doing? Result usize. So perhaps we just, does this make any sense? Let me just try to run it now, see what happens. Okay, that didn't work. You know what we're gonna do for now? We're going to do this. Great. However, now let's try to actually run it. Very interesting. How was it doing it over here? Read line. So, So maybe we need this handle. And then we say handle the read line. Still, maybe it's because I'm running it inside Emacs. Let's try to go out of Emacs and say Kabul run. Okay, so now it kind of worked, except it didn't flush after this. But I guess we can say IO std out flush. Flush. Okay, let's leave that for now. But here we have the basic structure of the interpreter. Okay, until next time.